Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to discuss solution of the problem that is subtraction in linked list. First of all, let us start by understanding the question. What does question say? Given two linked lists that that represent two large positive numbers. So we are given two linked lists that are representing positive numbers. What does that mean? We all know in linked list there are nodes connected to one another. So here all the nodes will contain one digit each of a positive number. So when you combine all the digits, you get a positive number. Okay. The task is to subtract the given two numbers represented by the given linked list. So we need to subtract the given two numbers. Subtract the smaller one from the larger one. So our answer will always be positive. So for example, if the first linked list contains 10 and second contains 20, then also we will return 10. And if the first linked list contains 20 and second contains 10, then also we will return 10. Okay. And we will return answer also in the form of a linked list. Okay. So if my answer is 10, I will have a linked list where first node represents 1 and second node has the value 0. And then it is the last node. So next pointer to it will be null. Okay. Iteration over the linked list signifies going from left to right digits of the decimal number. So when you traverse the linked list starting from the head node to the tail node, it represents a number from left to right. So if the digits are 102, so the number is 102, not 201. It is 102. When you go from left to right, it is the left to right digits of the number. Okay. For example, if the linked list first contains 100 and second contains 12, so first represents 100, second represents 12, so your output must be 88 because 100 minus 12 is 88. Okay. And you will return a linked list like this. Okay. First linked list contains 0063. So this number is 63 and second is 710. So the larger is 710. So 710 minus 63 will give you 647. 0063 subtracted from 710 gives 647. So there might be leading zeros also in the starting. So you need to take care of that. Okay. You do not have to take input or print anything. Your task is to complete the function subtract linked list that takes heads of two linked lists as input parameters and which should subtract the numbers represented by the given linked list and return the head of the linked list representing the result. So our result should also be stored in a linked list and we will return the head of the linked list. Okay. N and M are the length of the two linked lists respectively. The expected time and auxiliary space both are big O of n plus n. So now if we think about solving this problem, then see basically we are given linked list where two linked list both of which represent positive numbers. Now any linked list can represent greater number. Okay, this number might also be bigger, this might also be bigger. We need to find the difference, means we need to find the larger minus smaller value and we need to store that result again in a linked list and then return the result. Also, please note, you cannot convert this into integers. For example, here you can convert it into 532, but here the number of nodes are very large. Let's say number of nodes are 1000. Then 1000 digit number you cannot store in any integer or long format. Okay, so that will overflow. So what we need to do is we need to follow the elementary upward subtraction path which we follow, and then we will store the answer also in a linked list. Okay. So for example, if you need to find 532 minus 64. So how do you do? Digit by digit. This will become 8, right? Here it will become 12 minus 6, and here it will become 468. How we did? 2 is less than 4, so we brought a carry from here. So this became how much? 12, and this became 2. Now 12 minus 4 gave us 8. 2 is less than 6, so we brought a carry here. This became 12 and this became 4. 12 minus 6 is 6 and 4 minus, here we assumed 0. So 4 minus 0 is 0 and we get 468. So that is what we are going to do. But from where we start the process, we start from ones place, then tens place, and then hundreds place, and so on. Also here, if there are no digits, we assume it to be 0. But we start the subtraction from ones place. So first of all, what I'll do is, I'll try to, let's say if I have two pointers, this is head 1 and this is head 2. First of all, I'll store the pointer to the linked list denoting larger number in head 1 because I want to find larger minus smaller. That only will give me correct answer, right? So how can I do that? See, here we cannot store them in integers, right? So we cannot store them and compare. So how do we compare which number is larger when we have two numbers? What we do is, let's say I have two numbers, 1, 2, 3, 4. and 1291. Okay, so which one is larger? How do I find? If the number of digits in one number is less than the number of digits in another number, then the number having more number of digits is definitely greater. But if the number of digits are equal, then how do? We start traversing from the left hand side, and at the first mismatching point where the digits are not same in both the linked list, whichever linked list has smaller value, that number is smaller. Okay, so here 1 and 2 are same, then 3 is smaller than 9, so this number is smaller than this, irrespective of what the values are further. For example, here it could be 99 and here it could be 11. Still this is smaller than this. Why? Because when we move from left to right, the first mismatching digit, whichever is smaller in that, that will be the smaller number. Okay, so here also what we can do is, first of all, what I said, I want to store the pointer to the larger number in h1. Okay, so the first thing which we are going to do is remove the zeros in the starting if there are any. For example, this number represents 64, but there are 2 zeros. So what I'll do is, I'll keep moving h1 and h2 further from the starting until we get continuous zeros. Okay, so for example, if the number is 604, then this 0 is valid. Okay, in the starting, if there are zeros, I'll keep moving forward. So first of all, I'll do that. So what I'll do, I'll say h1 equal to h1 next, h1 equal to h1 next. So my h1 will come here finally. Okay, and this will go away, and other number have no leading zeros. Okay, now what I will do, first of all, I need to check which number is larger. Here, how can I do? First of all, I'll calculate the length. Here the length is 3, here the length is 2, so definitely h1 is larger. Please remember, I'll start calculating length after removing the leading zeros. Okay, otherwise here the total length would be 4 and here the total length would be 3. Still this number is smaller. So first I'll bring h1 and then from here onwards I'll count the length. Here this is 2, this is 3, so this is greater. So I'll exchange h1 and h2. Okay, so here this will become my h1. Okay, this will become my h1 and this will become my h2. If the length was same, then what I would have done, I would have started moving from h1 to h2 until I do not get a mismatching point like here. Okay, and then whichever has the smaller value, I would store h2 for that linked list and h1 for the other linked list. In case all the numbers were same, for example 1 2 3 4 1 2 3 4, then I'll form a linked list having 0 and return it as my answer, because if all the digits are same, then my answer is 0. A minus b would be 0. So now what we have is, we have the larger number in h1 and smaller number in h2. Now what I need to do is, now this and this problem is same, right? Now what I said, subtraction starts from one's place and we take the borrow, right? So what I'll do is, I want to start subtraction from here. So I do not want to make it complicated, like I'll go till here, I'll go till here, then recursively come back, and no. I want simple. So what I'll do, I'll reverse the linked list. Okay, so if I reverse the linked list, then my h1 will contain what? 2, 3 and 5, right? And this would be null, right? And this linked list would contain what? 4 and 6, and this would be null, right? Now please understand, 4 should come below 2 when you subtract, because that is one's place. 3 should come below 6, and here we get exactly that. Okay, now one by one we keep moving ahead and subtract the digits. Okay, now here what I'll do is, and store the answer in a new linked list. Okay, so let's say this is my result linked list. Okay, so 2 minus 4, now 2 is less than 4, so I'll take a carry from here, so this will become 12. Whenever I take a carry, I'll increment 10 in the current number and decrement 1 from the next number. Okay, so 12 minus 4 is 8. So I'll make a new node and store 8. Then I'll move one step forward. Now this is 2, this is 6. So I'll take a carry. This will become 12 and this will become, why will this change? So this will become 12 and this will become 4. Now 12 minus 6 is 6 and I'll move forward. Now please understand, here h1 will point to this node and h2 will point to null node. Okay, right? So not h1 and h2, let's say I take 2 temporary variables to traverse the linked list. Okay, we do not disturb the head nodes. Okay, usually we do not disturb, because that is, if we lose head pointers, then we lose the linked list. Now whenever t2 is null and there is a number in t1, we consider this number as 0. We can do that here also, we considered it as 0. So 4 minus 0 is what? 4. right? And then T1 becomes null, so I'll end a null here. Okay, now please understand, this is the result which we have got. This is ones place, this is tens place, and this is hundreds place. So after obtaining the result, I'll again reverse the linked list. Okay, so if I reverse the linked list, I'll get result, I'll get 4, I'll get 6, and I'll get 8, and I'll get null. Okay, so this is my answer linked list, which it should be 468. Okay, now I'll briefly tell you how do we reverse the linked list. So what we do is, let's say I have this linked list. Okay, so if I want to reverse this linked list, then what will happen? Let's say this is 1, 2, 3, 4. Then my reverse linked list should contain 4, 3, 2, 1, and the head pointer should change, right? Now we do not want to change the values. Okay, we want to play with the pointers, like node values we are not going to change. Okay, a simple way could be create another linked list in which you store the number starting from 4, 3, 2, 1. Okay, but if you want to reverse the linked list, what you do is initially you take previous equals to null and current equals to your head node and one next pointer. Okay, now while your current is not equal to null, what you do is you say current next equal, first of all you say next is equals to current next. Okay, so your current is here, your previous is null, so your next will come here, right? Now you say current next equals to previous. So what will happen? This is current next. When you say current next equals to previous, previous is null, so this will start pointing to null. Okay, and now you say previous is equals to current. So your previous node which was null will now come here at current position. Okay, so this will come here, right? So this will be your previous pointer, and then you say your current equals to next. Okay, so your current pointer which was here will now be pointing here. Okay, right? Done this much. So this is your one loop. Now what will happen next time? Next is equal to current next. So first of all next will come here, right? Then current next equals to previous. So this is current next. And what is previous? Previous is this node. So what will basically happen is, this is current next, right? So current next will point to previous. Then previous equals to current. So now previous will become this, right? And current equals to next. So this will become current. Now in the next step, this will point here and this will point here. And finally, after coming out of the loop, I will say head equals to previous. Because when we come out of the loop, our current will become null and our previous pointer will be pointing here. So my new head pointer will be here. So this is head, then this points to 3, then this points to 2, and this points to 1. Okay, and this is pointing to null. Okay, previously. Now, and the new head pointer is here. So this will also go away. So this is how we reverse a linked list. Now let's look at the actual implementation of this problem. Okay, so let's look at the actual implementation. So this is the function which I need to complete. Subtract linked list. I have head pointer 1 and head pointer 2. First of all, until head is not null and head data is 0, I'll say head equals to head next to remove the starting zeros. Similarly for the next linked list. Now if both of them are null, if head 1 and head 2 both of them are null, means both of them were 0 initially, then I will create a new linked list containing only one node in which the result is 0 and I will directly return it. If not, then I'll find the length of first linked list and second linked list. If the length of the second linked list is greater than first linked list, then I will swap, because in the first linked list I want larger number. In case both of them were same, then I'll take a temporary pointer to head 1 and temporary pointer to head 2, because I want to find which number is larger, right? So how do we find? Starting from the head, I'll just keep traversing until I get a first mismatching point, and whichever number has the larger digit at the mismatching point, that number is larger. Okay, so here I will say while T1 data equals to T2 data, while they are same, T1 equals to T1 next and T2 equal to T2 next. Okay, now if T1 becomes null, it means please understand, because of this step, T1 will either have, head 1 will either have a linked list with larger length or same length. Okay. So in this if condition, we are only going when the length are same. So if I check either for T1 or for T2, it will work. So when we were saying the data is same and at a certain point of time, if T1 becomes null, it means both the numbers were same, 1, 2, 3, 4, 1, 2, 3, 4. That's why we got a null value. So I'll directly return 0. Okay. And if after coming out of the while loop, if the data in the second linked list, that is T2 data is greater than T1 data, this is the mismatching point, because we will come out of the while loop when we get a mismatching point. And if all the points were same, we would have written 0 from here only. So in mismatching point, if the first linked list has larger value, then it's okay, because in first linked list we want a greater number. But if it is in second linked list, that is T2 data is greater than T1 data, then we need to swap. Okay, then I'll swap head 1 and head 2. Now I'll reverse the linked list as I said. So I'll say head 1 equal to reverse and head 2 equals to reverse. Let's look at the reverse function. So this is the reverse function. Okay, so previous is null, current is head, and next is simply nothing. And while current is not null, next equals to current next is previous, previous equal to current, and current equal to next. And the head of the new linked list would be previous. Okay, so you can return it. So our reverse is done. Now I want to store the result. So I take a new linked list with the head pointer result, which is null, and last is null. Why last? Because let's say here first I was operating here, then I was operating here. So one node I stored here, then second node I stored here, then third node I need to store here. Now let's say there was another node. So if I want to store a node here, I need to traverse till here and find which was the last node. Instead, I am keeping a track of the last node or the tail node. So initially tail node will be this. So I'll insert a new node here. Then I'll update the tail node to here and insert the new node here. Then I'll update the tail node, and if required, I'll insert a new node here. Okay. So it takes me constant time to add a new node at the end of the linked list. Okay. So that's why I have taken last variable also. Now T1 temporary pointer 1 is head 1 and temporary point 2 is head 2. While T1 is not null, I'll say a smaller number as 0. So whichever number is smaller. Okay. And if T2 is not null, then I will say smaller equals to T2 data. So small is the number in the second linked list. Okay. Now if T1 data is less than small, then I need to take a borrow. So what I'll do, I'll decrement the value of the next node by 1. So T1 next data is T1 next data minus 1, and increment the 10 in the current node. So T1 data equals to T1 data plus 10. Okay. Now I want to store T1 data minus small as a result in the linked list. So what I'll do, I'll say new node equals to T1 data minus small. Now if the resultant linked list is null till now, then I would say result equals to this pointer only and the new node which I created, and last pointer is also same. Else if it is not the case, then last next will be equal to n. I will insert a new node at the end and I will say last equals to last next. My result is the head pointer of the result. Okay, it will not change. And I will go to the next node. So T1 equals to T1 next, and if T2 is not null, then T2 equals to T2 next. Why am I checking if condition for T2 here and here? Because T2 might be a smaller linked list. It might get over first. That's why. And finally, I need to reverse the resultant linked list also. So result equal to reverse result. Okay. And after reversing also, if there are zeros in the starting, then I will remove them. Okay. And then say, then finally return the result. Now, after reversing, why I need to remove the starting zeros? Because, for example, if your numbers are 112, okay, this is the given example, then your linked list would be 100, 0, 0, 1, 0, 0 and null, and this would be 1, 2, right? So you reverse them. So this becomes 0, 0, 1, and this becomes 2, 1. Okay. Now you subtract them. So this will become 10 minus 2 is 8. This will become 9 minus 1, 8. And this will become 0 minus 0, 0. Now this is your resultant linked list. You reverse it finally. So it became 0, 8 and 8, right? And this is your null. And this is your result. But 0 is not in the answer. Our answer should be 88 only. So what I'll do, I'll remove this. I'll take my result pointer to here and then return this. Okay. So that was about the implementation, and finally we'll return the result. How much time complexity it takes? Time complexity is big O of n, because reversing the linked list takes n, big O of n. We saw the loop. Then subtracting also takes big O of n. Finding which number is larger, length of the linked list, all takes big O of n. And if we are performing all operations a few times, it is a constant multiplied by n, where k is a constant, we can remove it. Okay, or not n. Okay, just a second. It is n plus m, because the length of the first linked list is n and the length of the second linked list is m. So it is n plus m. And what is the auxiliary space required? It is also big O of n plus m, right? Because here what we are doing is we are also storing the result, right? So it will also occupy the space. Now let's submit this code. So let's submit it. Okay, so we have solved this question successfully. I hope you have understood the solution completely. Thank you.